Let's start with the first problem, and it is, what is the time complexity of the following function? This function loops through the array from index 0 to n minus 1, and this means it runs n times. Let's write informations here. Runs n times. Okay. And inside the loop, there is a if condition, and this if condition checks the array elements are negative or not. Checking a condition takes a constant time, and it is O1. Let's write this. Checking the condition takes O1 times. And since the loop runs n times, and checking the conditions takes O1 times, so let's multiply them and find the result. O n times O1 equals O n, and here is the result O n. Let's continue with the other problem. What are the time complexities of the following code fragments? And left side, first one, here, it runs n square times. Runs n square times. So our time complexity is here, O n square. And second one, here, it runs n square over 40. But when we calculate the time complexities, constants are ignored. So here our time complexity is O n square. Next one. Here it runs n times. N times because n times n over n equals n. So runs n times here. And then here our time complexity is O n. Next one. It's kinda complex. Let's write n times n over 3 minus 10. Let's put some parentheses, and again over 2. It runs this time, and it's about n square times n square times So here our time complexity is O n square. Next one. Here, as you can see, there is a huge number, and this is a fixed number of iterations, and it is not dependent on n. So here our answer is O1. That's all. And right side, let's continue the right side here. Here it doubles each time, doubles each time, like 1, 2, 4, 8, and goes like this until n. So here our time complexity is O log n, right? O log n. Next one. Again similar with fifth one, runs a constant number of times. Here it depends on n, but stop early. So our answer is again as fifth one, O1. Next one. Next one is a nested loop. There is a 2 for statements, and the other loop here, the first 4 statement, it is other loop, runs O(n) times. It runs O(n) times. And the inner loop here, and it runs O(m) times. And the total time complexity is O(n) times O(m), and it is O(n)m. And the last one is, it's similar with the 8th one. Again, there's 2 for statements. First one is other loop, and it runs O log n, O log n, and inner loop O(m) runs O(m). The total time complexity here is O(m) log n. Okay, and then next problem is, what is the time complexity of the following power function? And here is this function calculates power using recursion and division. There's base case. These are base case. This one. When n is 0, it returns 1. When n is 1, it returns x. Let's write here. Base case. And then here, if n is even, we calculate power like this, and if n is odd, like this. Okay, when n is even, we can write x power n as power n as x squared power n over 2. When n is even, we can write as like this. And when n is odd, we can write x power n as x times x square power n over 2. Here, in each step, n becomes n over 2. And this means the number of steps required is about log 2n. So here, the total time complexity is O log n. Okay, and other one is, what is the time complexity of the following Fibonacci function? If n less than 2 or equals to, it returns 1. This is base case, And otherwise, it calls itself 2 times. Recursive fib n minus 1 and recursive fib n minus 2. It calls itself 2 times. And then this creates a binary tree of function calls. Each function call creates 2 more. So here is our time complexity is O 2 power n. Here is the answer. Okay, the last problem is faster computer or algorithm. Suppose we have a fast computer that is 10 times faster than a slow computer. We have a problem with 2 different solutions. Fast algorithm takes O(n) time and slow algorithm takes O(n) squared time. The question is, which is faster? Slow algorithm running on fast computer or fast algorithm running on slow computer? Which is faster? Let's find out. Okay, fast algorithm takes O(n) and slow algorithm takes O(n) squared time. Slow algorithm running on fast computer is slow algorithm O(n) squared, and slow computer is O(n) times. Okay. And fast computer is O(n) over 10. And slow algorithm running on fast computer is O(n) squared. Let's write O(n) squared over 10. And this is the time complexity of slow algorithm running on fast computer. And fast algorithm running on slow computer is just O(n). Okay. Which is faster? Fast algorithm on slow computer is better, but for large n, you know. If n is less than 10, the other option is suitable. Let's write the result. Fast algorithm. Fast algorithm on slow computer is better for large n. Okay, that's all.